need to turn in today from when she was gone on Monday. So you'll have homework 12, homework 13. You'll have a quiz from last class and a quiz today. And from what I understand, the quiz was emailed.
Sorry.
But I've got plenty of copies here. So raise your hand if you don't have a quiz. 13. Okay, welcome to you. Review. And I'll be here for a little bit after class too, if you've got questions on your homework. I teach math, so it's all good. Good to see a few of you again. Okay, so let's get started, all right? Today we're going to be talking about rational expressions, okay? Rational expression, we'll get to the definition. It's basically a ratio of two polynomials. One polynomial divided by another polynomial. It's like a ratio. Okay, get to it. We're going to be doing simplifying of those messy expressions to their lowest term. And that means dividing out from the top and bottom everything that can be, everything that matches. X divided by x equals 1, so it goes away, as an example. Okay, we're going to be talking about factors that are opposites. We're going to tell you what that is all about. An opposite is the negative of a thing. So the opposite of 3 is negative 3. The opposite of x is negative x. Okay, pretty simple. It's just the negative of it. And we're going to be doing some multiplying and dividing of these expressions. Yeah, and there's fractions involved. But it's all good. It's really simple, and we'll get to it. We got plenty of time. Okay, so let's start off. Rational expression, like I was saying, is basically the quotient, that means to divide, okay, of two polynomials. So you're going to have one polynomial divided by a second polynomial. The polynomials can have any number of terms. They can be a binomial like this, x plus y. They could be a trinomial. They can be whatever, okay? It's just one divided by the other. And here's a few examples. Do y'all have notes, like a note packet? Okay, awesome. So you can take notes on here, on there. When we're talking about something divided by another number, a number up top and a number on the bottom, there is a special case. When the bottom number is 0, it makes it completely not work in the known universe, okay? You cannot have a 0 in the bottom. You can ask Albert Einstein, okay, Copernicus, nobody knows what dividing by 0 means. It's basically undefined, okay? So that's what we mean by undefined. Undefined is when the bottom is equal to 0. Hey, come on in.
I think mechanical engineering proves it to be infinite.
Infinite? Okay.
Because if you have an adding machine that's mechanical, it will need to be unplugged and reset, or it will keep going until it breaks itself.
Okay. Well, the key is that it breaks itself.
But
It can't ever get there. Yeah. It's undefined. Yeah. Welcome. My name is Krista. I'm teaching today and next week as well. Okay. Here's my email address in case anybody needs it. You can also copy Mrs. Barbier. Okay. She'll want to know what y'all have questions with. So when we're talking about undefined values, whatever happens to make the bottom value equal to 0 is an undefined value, okay? It's out of bounds, doesn't work, it's not okay, all right? So here's an example. Values for which the rational expression is undefined, okay? In other words, what values make this whole shebang equal to 0 on the bottom, okay? So we're gonna focus on the bottom. Yeah, there's some stuff up here, okay? This might be able to be factored, okay, that's all right, but really we're focusing on the bottom to get that undefined, all right? So we're gonna set x squared minus 9x plus 18 equal to 0, because we wanna figure out what values of x are gonna make this guy equal to 0.
Okay.
Right, so this is just an extension of what we've already been doing with factoring. So we're gonna take this guy, set him equal to 0. We're gonna factor him, and you can use whatever tools you need. I see a few of you have your charts out. Awesome. Do the big X-Men. All right. I'm going to go ahead and assume that y'all can factor that guy into x minus 3 and x minus 6. All right. A little bit of review. If this second sign is positive, it means that both of the signs in your factors are the same. Okay, and that they're negative. Okay, a little bit of review. But in any case, the way to check these, as always, is to multiply it out and make sure it adds up and multiplies out properly. That's how you check. So we've got x minus 3, x minus 6 equals 0. We're gonna set each one of those factors equal to 0. Because if you remember, if x minus 3 equals 0, come on in. Or if x minus 6 equals 0, then this expression is true. You good? Okay. Let me brief. Wait, are you okay? Okay, awesome. And Lista? Okay, cool. I think we got almost everybody. Okay. So, come on in. Getting back to this, x minus 3 equals 0, or x minus 6 equals 0. So that turns out to be x equals 3 or x equals 6. So what does that mean? All right, if x is equal to 3, or if x is equal to 6,
Does it mean both values will work or only one?
it means either one will work.
Okay.
Either one.
I mean either, not both. Either.
Yeah. Either x equals 3, plug that back in, and you'll get this bottom expression equal to 0. Or if you plug in x equals 6, you'll get this bottom expression equals 0. So we know that the expression, this whole shebang, the whole polynomial up top and on the bottom, this whole thing will be equal to undefined if these, okay, those are your two cases. So that's your answer. What values of x make this expression undefined? These values of x will make this 0, and therefore the whole thing is undefined.
Does that basically just find out what x can't be in an
Correct.
equation?
Yep, it's not allowed to be, yeah. Okay. Let's see, we've got Isabel. Okay, welcome. My name is Krista. I'm gonna be teaching for Mrs. Barbier. Do you need a quiz or do you have one? You need it, okay. No problem. All right, let's move on. Okay, so what we just talked about was called a domain restriction, blah, blah, blah. What is that about, domain restriction? It's basically a restriction on what x is allowed to be, okay? So if x is not allowed to be 3 or 6, kind of looks like this, and not equal, can't. That's what that means, domain restriction, okay? It's just another way of saying it. Does anybody see one of these that they want to raise their hand and call out right away what they think, like 1, 3, 4, which one of these?
I'm curious about x not being equal to 1, so I kind of need to think about it, but
Well,
yeah, I'm
so
lacking context, I think.
if x can't be equal to 1, all right, we're just going to single that guy out because it's kind of front and center. It means that if we plug in x is equal to 1 for one of these, it's going to turn the denominator, the bottom, to 0. And we can't have a bottom equal to 0 because then it will be undefined. Okay, so if x cannot be 1, one of these, gotta plug that in. Looks like this guy.
Okay.
Okay, because if I plug in a 1, to this x minus 1, I'm gonna get 0 on the bottom. I'm gonna get 5 over 0. And that's undefined. Can't do it. No bueno. Infinity or whatever. But cannot have it. Okay? Can't divide by 0. It's restricted. Okay, so let's take a look at this guy, number 3. We have x as a factor and x minus 5 as a factor. Okay? So it looks like we're going to have 2 values for x that could be making that denominator equal to 0. So number 3, we've got either x equals 0 or x minus 5 equals 0. In this case, here's our first one already. If we plug in x equals 0 here, it's going to be 0 times something else, which is 0, making this whole thing undefined. You follow? Or x minus 5 equals 0, and therefore x equals 5. Okay.
Oh, that's why that's that.
Yeah. So if x is equal to 0 or 5, this guy will become undefined. It'll have a 0 in the basement. Okay. Another example right quick. Number 4, that's an easy one. It's only got one term in the basement. We've got x minus 3. We know that it's restricted, can't do it. That x minus 3 cannot be 0. So let's figure out what would make this 0. Anybody? Raise your hand. Okay, go ahead. 3, yeah? Agree? Want to fight? Okay. Yep, here it is. X cannot be equal to 3. Or else that number 4 will be undefined. Okay? Okay. Bueno, let's move on. Alright, so we talked about undefined, alright? It's just we're looking at what's in the basement. You can't have the bottom equal to 0. Now we're going to talk about a different thing to do with these rational expressions. Again, a rational expression is one where there's a polynomial on the top and a polynomial on the bottom. In other words, it's a ratio of one to the other. Okay? This is the same as x divided by y. Okay, fractions. This is rational expressions. Okay. So we got a rational expression right here. I know there's a lot of noise, but this is what we're given. Okay? So we're going to simplify it. And simplifying means we're going to pull out everything that's the same from the top and the bottom. Whatever is identical from the top and the bottom, we're going to cancel it out. Cancel out. What does that mean? That means if I have an x divided by an x, that becomes 1, right? Or similarly, a 2 divided by a 2, that becomes a 1. That cancels out because we don't write the 1. 1's kind of invisible, comes along for the ride, all right? So in this case, we've got 4x cubed, 4x to the third, up top, 6x squared down below. So we're going to see what we can cancel out of this, all right? We're going to see what we can divide out. What is identical? Thank you. What is identical on the top and the bottom? That's what we're going to simplify out. We're going to cancel out. Well, so another way to write this is 2 times 2 times x times x times x. It's because these things multiplied all together equal 4x to the third. 2 times 2, those are the factors of 4. Here down below, 2 times 3, those are the factors of 6. And then we've got an x and an x and an x. 3 of them. Down below, we've got 2 of them. Okay? Are there any questions about how this turned into that?
Did it turn into not equal to -3 or 3?
-3? 3?
Because we ended up with x over 3 was what was left for that to be 0. Would that have to be x equals
You're way
not
ahead of
equal
me.
to
You're way
okay.
ahead of me. Okay.
Sorry.
I got you. No, it's all right. We'll get there. good.
I thought I missed something.
You're all good. So, coming back to this, we've got 3 x's up top and 2 x's down below. Let's go ahead and cancel out whatever is the same above and below, okay? 1 up top, 1 on the bottom. 1 up top, 1 on the bottom. When I draw a line through them like that, they're called canceled out. They go away. You know, they hold hands. They become one and go off. Nobody ever see them again, okay? And up top, we also have a 2 and a 2. Another way to
Bless
think of this is that 4 and 6 are both even numbers. They're both divisible by 2. So if we divide the top by 2 and divide the bottom by 2, we're left with a 2 up top and a 3 down below, okay? I wish I do have colors. Does this work? Yes, nice. Okay, so that's what's left, okay? After we start canceling stuff out, we have a 2 and an x up top and a 3 down below. So that's what that simplifies down to, okay? That's what we're doing, is simplifying a rational expression. It means reducing it down, taking out all the fluff. The same from the top, the same from the bottom. They go away and we're left with something much smaller, much more simple, okay? Okay, so good question over here a few minutes ago. X cannot equal 0. And how does that marry up with this?
There's 2x over 3x.
Well, the answer is it doesn't. Because when we're talking about domain restrictions, okay, what is X not allowed to be? We have to go back to the beginning. We have to go back to this. It's not related to this. Okay, there's 2 distinct problems here. One of them is simplifying, and one of them, the second one, is what makes this expression undefined. Okay, so this is the simplification. That's all good. But what makes this expression undefined? We got to set the denominator, the bottom, equal to 0 to find that out. And we get x can't be equal to 0. And that's because 6x squared equals 0. Once we divide everything out, x can't be 0. Okay, so just to be clear, there's 2 problems here. One, the simplification, and the other, what is making this expression undefined. Yes?
So whenever there's more, or like there's a higher power x on the numerator than there is on the denominator, x will always not be 0?
Correct. In your simplification, okay, but before we simplified it, we had this noise,
Yeah.
and it's gonna be undefined when x is equal to 0. So like 6 times 0 times 0 is equal to 0. Yeah?
So for like homework problems and quiz problems,
Mm-hmm.
are we looking for what x cannot be? Or
Good,
is-
that's a great question.
Yeah.
And so my answer will be, you gotta read the problem carefully.
Okay.
Do they want you to simplify it? Awesome, then do this. Are they looking for what values make that expression undefined? Do this. Okay, and they'll tell you in the problem. It won't be vague. Okay, cool. Let's do another one, okay?
6x squared equals.
Another example.
It's just because there's no, if you're multiplying it by anything and coming up with 0, it has to be 0. So if you have an unknown variable on the top, I mean, now I'm hard pressed to think of reasons why it would be anything but 0. Would make it undefined.
There is no other value other than 0 that will make this undefined.
But,
Only
or if
0.
any number was next to a variable on the top.
The top, when you're finding this number, the not can't be equal to, the top is irrelevant, doesn't matter. The top comes into play when you're going through and simplifying, okay?
Yeah, I'm
So-
looking at that.
Yeah.
But 2x over 3, I'm still just not extrapolating 0.
This is not related. Separate. This is one part of the problem, and this is the other part of the problem.
Oh,
They're
we
not
already knew
related.
that x equals 0.
X cannot equal 0.
Or
or
we know
it
that
can
x
equal-
is
yeah.
not equal to 0.
Okay, let's move on. We're gonna go ahead and factor the heck out of this guy so that we can see what we can simplify. We can see what is the same on the top and the bottom. The top, 5x plus 10, we can factor out a 5. Okay, cool. And we're left with 5 times x plus 2. Okay. On the bottom, we've got x squared, 6x, and 8. And you can use your x, you can use your chart, you can use your, I guess I already figured that out in my head. That works too. Your factors are these two. Okay? I'm not gonna factor these because I think y'all have your methods for doing that. So this guy right here is the same as that guy, all right? This one is just factored. So now we've got a 5 multiplied by an x plus 2 up top. We got an x plus 2 and an x plus 4 on the bottom. There are things that we can cancel out and turn into 1, okay? These guys, x plus 2 and x plus 2 are gonna disappear, become 1, never see them again. And what we're left with is the 5 and the x plus 4. So our simplified expression, come on babe, come on down, there we go, is 5 divided by x plus 4. Cool? Okay, cool. So if we were looking for what values make this expression undefined, we gotta go all the way back to the beginning. Here we are. What values of x will turn this into 0? Well, we've got our factors here. We've got x plus 2, set that equal to 0. And we've got x plus 4, set that equal to 0. We're gonna get 2 independent individual values for x that will turn this denominator to 0 and therefore render this undefined, okay? Anybody wanna shout out what these are? Yep.
-2, -4.
That's right, so x cannot be -2 or -4. Okay, yes.
Why wouldn't it just be -4?
Because
Well, it is -4, but it also is -2. So the answer is either -4 or -2. Either one of those plugged into this will turn it to 0. Yeah, and that's how we found out. This one could be equal to 0, and it'll be 0. This whole expression will be 0, or x plus 4 could be 0. Anything multiplied by a 0 turns to 0. So if either one of these is 0,
anything divided into 0 is 0 though?
Correct.
That's what my problem was on the last problem, because 3 is going into 0.
yes.
That's why
and-
it's not -3. Alright.
Yep, okay, good. Okay, cool. Yeah. A 0 up top is totally okay. A 0 on the bottom is not allowed. Not okay. Okay. Let's crank. Okay, so we're going back to simplify. Another word for that is to reduce it, okay? To simplify it, reduce it down, distill it down, get out fluff, whatever's the same up top and on the bottom, we're gonna cancel out, okay? The easiest way, so we look at an expression like this guy, this rational expression, right? Something up top and something down below, rational. I don't know, yeah, it's reasonable, it's rational, it makes sense. No, it doesn't like that. A rational expression is something up top and something down below. It's a ratio. That's what that comes from. But in any case, here we go. This is what we're going to simplify down to lowest terms, okay? When we say lowest terms, what does that mean? It means canceling out as much as we can from the top and the bottom to reduce it down as far as we can, okay? These are all kind of words and language that mean the same thing. This is the same as this, okay? It's all the same. Simplify, reduce, distill, all the same stuff. So when we look at this right away, there's nothing to cancel out. It looks like that one's not related to the bottom. Top and the bottom are totally different until we take a little bit of a closer look and we factor the top and we factor the bottom, okay? So we're gonna factor the top here and we're gonna factor the bottom here, okay? This guy right here is a whole separate problem, okay? We're gonna be working on the first part first. So with the x not equal to, figuring out what the domain restrictions are, aka what can x not be equal to. This question right here, this little problem to solve, is not listed up here. It's not. Okay, so when you were asking how do I know what to do, if you have a quiz or homework or whatever, they will definitely specify. This is just written here, I think, just for extra info, extra credit, whatever. Just so you know, we can also solve that thing too, okay? But it's not required here, so we can ignore it for now. So let's go ahead and factor the top and factor the bottom into two binomials. Yay, factoring practice. Let's go ahead and change these into their factors. So I'm not gonna draw the x's or use the chart or whatever, because somebody already did it for me, so I don't have to. That's your job. So the top, we got an x plus 3 and an x plus 4 up top. Down below, we've got an x plus 4 and an x minus 9. Okay, everybody see how that happened? We got two messes, and they simplify down into this. And now we got something that we can cancel out. Looks a little bit easier to approach. We got an x plus 4 and an x plus 4, and they go away, and look up, and we never see them again. They turn to 1. They're gone. So we're left with this.
Can we eliminate those x's really? Can't we? Because they
So
divide
that's
to each other?
That's a good instinct.
So it's
So you have an
3
x
and
up
9?
here and an x down here, but Lamo, you cannot.
Okay.
And the reason you cannot, I mean, that's good that you saw that, but the reason you cannot is that these are attached to their neighbors by addition and subtraction. If they were multiplied, like this guy down here, for a side example, okay, if they were multiplied like this, an
Or
x
negative 9x.
times a negative 9, if, which they're not, but if they were, then you could say, great, those x's are gonna go away, this goes away, this becomes a negative 3, and you'll have
Yeah.
negative 1/3, negative 1/3, all the same, okay? But since they're not attached by multiplication, you have to leave them as they are, okay? Everybody get that one? That's important. All right, good question.
Okay.
I'll leave it up and then we'll carry on. Okay, so to Tim's point, one of these is the right way and 3 of them are the wrong way, okay? So we're gonna discover which one. First of all, I'm gonna just tell you which one it is, okay? This one down here, number 4, is correct. All right, and I'm just gonna go through briefly how come that is. So if we take a look, each one of these examples has the same problem, okay, the same rational expression, all right? If we take a look at this, if we were Tim before this class, we'd be like an x squared up here and an x squared down here, we're gonna cancel those, right? We got a 12 and a 6, I can do some division here, okay? But this guy is not right because these guys are attached by addition and subtraction, okay? So that's not right, can't do that. Can't divide that way, okay? Here's another one, another attempt, okay? Still wrong, but here we go. So what we just learned is we can take each of these things and factor them and look for common factors and cancel them out, okay? This top guy, x plus 4, x minus 3. Anybody see any issues?
Factoring.
Yeah. That's not right. This factorization is incorrect. So they got this part wrong and carried on. Now the method is right. If you got something the same up top and on the bottom, you cancel it out and you simplify, but this factor is not right. So they kind of diffed it out of that. Okay, let's keep trying, okay? Let's see, we've got correct factors here, x plus 6 and x minus 2, correct factor of this guy. We've got x minus 2 and x minus 3, correct factor of the bottom. So we're gonna cancel out our x minus 2's, and we're left with x plus 6 over x minus 3. Looks pretty good, all right, here we are. And then somebody was like, no, keep going. There's still more. And they're like, there's an x up there and an x down below, so cancel and, you know, divide. That's no bueno. You should have stopped, because those are attached by addition and subtraction. So they're stuck like that. There's no more simplification to be done, okay? Number 4, oh, let's not do that. Number 4, stop at the right place. Okay? Questions?
That's not a finished answer though, right? Or is it?
Which-
At that
well-
point,
As
if it was
far
just
as it's
asking for
getting-
simplification, would that be complete?
That is complete.
But what if it's asking for like the actual answer, it would be -6 and +3, or no?
No.
No?
So let me just brief. Okay.
Okay.
First of all, what's written on your quiz or your test or your homework is which one of these is correct. Like which one of the methods is correct.
Yeah.
So number 4 is your answer. Okay. So if it's asking you to simplify, correct, that is your answer. You would write this in your box. Write this in your blank. Okay. If they're asking you for which values of this expression is undefined, then you go back to your original, and say, I'm gonna set the bottom equal to 0 and see which values will make the bottom 0. Okay, so they're 2 entirely separate problems. Okay, this is 1 and this is 2. So in the case of where is this expression undefined, x cannot equal 2 or 3,
Okay.
if it asks for that, okay? Cool?
Cool.
All right. Let's carry on. All right, so I mentioned this on the first slide. We're gonna be talking about factors that are opposite. Real easy, a thing has an opposite when you put a negative in front of it, okay? The opposite of negative x is x. Yes, correct. The opposite of x is x. The opposite of 3 is negative 3, okay? Cool properties of opposites. When you divide a number by its opposite, you will always get -1. Good to know, okay? Example up there, 3 divided by -3 equals -1. That is a number divided by its opposite, turns it to -1, okay? I know that sounds simple, but it's important when we go on. So, let's give it a shot here. So we've got an expression, a minus b, okay? You can also write that as, yep,
Never mind, I will wait.
okay, yep, stand by. You can also write it as A minus B in parentheses, same deal, okay? When we take the opposite of A minus B, we put that negative in front of it, right? It's the negative of that number. When we, or just, fun, because we love to do that, when we distribute our negative inside those parentheses, we're gonna get negative A plus B. In other words, we're going to get B minus A. Okay, so A minus B and B minus A, we just swap around those two variables with a negative inside. Those are opposites. And as we just learned 2 minutes ago, when you have a number and you divide it by its opposite, you'll get -1, okay? So A minus B divided by B minus A, -1. Math. It's fun. Okay, what if I saw this and I don't remember, I didn't understand that, I don't get it, whatever. And I have to divide these. What do I do with that? Well, you can try and factor out a negative from one of these, okay? So like, I'm gonna factor out a negative from B minus A, okay? I'm gonna factor a negative out. So like, I'm gonna put that negative, and this becomes a minus B, and this becomes a positive A. In other words, it's the same as a negative A minus B. It is the opposite of A minus B. When I divide A minus B divided by its opposite, I get
-1.
correct. Thank you. I get -1. Okay, so that's all we're talking about here. We're just talking about, how do I get rid of that guy? We're just talking about opposites, okay? If you have a number and you divide it by the negative of it, you'll get -1. I know, I moved something, didn't I?
Right there.
Brilliant. Okay, all of this mess is just another way to say that. Okay, cool. So let's go on. Okay. What are we doing here? We are going to factor some stuff. Okay, so I think even though they didn't write it, I think what they're asking us to do with this is simplify. Okay, simplify to lowest terms. Alright, simplify that number 1 green box. So we're going to factor the top and we're going to factor the bottom. Okay, anybody know what goes in this box?
5.
Yeah, 5,
Alrighty.
okay. More specifically, x minus 5, but there it is, okay? And the bottom, does anybody remember this type of special circumstance? This is called the difference of squares, okay? Where you get a square minus another square. Yep,
X plus 5 and then X minus 5.
close,
What?
very close,
Oh,
right? There you are. Well, I'm seeing it. Okay, so we got a 5 minus x and a 5 plus x. That's important, you gotta get your order right. Okay, so what do we see here? We got an x minus 5 and a 5 minus x. What? X minus 5 and 5 minus x, they're real close.
That's that 1 and -1 essentially, right?
Yeah, so we have a number and its opposite down below, right? Look here, a number and its opposite down below. X minus 5 and 5 minus x are opposites. Okay, so they look real close, they look the same, but instead of canceling out and becoming 1, they cancel out and become -1.
Will that swap now the signs of the other two that haven't been?
So, okay, stand by. We're gonna do this, and we're gonna do this, and we're gonna write a -1 here, okay?
Yep.
Cool. And we're gonna keep everything else the same. We don't need to swap anything else around. We just need to convert those guys into a -1. And so, all of these little examples here, They're all answers. They are all exactly the same. This one has a negative here. This one's got it down below. It's the same thing, okay? This one's got it out front, same thing, okay? And this one, we took that -1 and multiplied it in, rainbowed it inside. Same thing, okay? They're all gonna work. They all get the right answer. They look a little bit different, but they mean the same thing. Cool. Okay. Were there any questions on that one?
So we just put the negative in front of the, sorry, what's that?
Yep, keep going, you're all right.
To write it as, you know, as our homework, that -1, you're just gonna put it in as one of those 4 expressions, or?
Yeah, for when you simplify this guy on your homework, or your quiz, your test, whatever, you can write any one of these 4. They're all correct. So if you're happier putting that negative up top, or down below, or out the front, whatever works. They're all the same. I personally like this guy. Personal preference. It's not confusing. Okay. How we doing? Multiply and divide. Okay, yay. So, we got fractions. Everybody loves fractions, right?
Yeah.
Everybody loves fractions. Fractions are the best. Okay, so rules of fractions. Are we having fun? Okay, rules of fractions. I'm gonna just take a quick sideline here in one good hand. And I got A, and I got a B, and I got a C, and a D. Pretend that these are, because they are, rational expressions, okay? I got a thing divided by another thing. When I multiply them together, use the dot, or use the parentheses, same deal. When I multiply them together, I get A, C, B, D. Anybody want to fight me on this one? Okay, cool. If I have A and B and I divide C and D.
What?
Okay, stand by, you're all right. I'm telling you how it goes. The answer is when we're dividing, we take this guy and we flip it. So we're gonna get A, D, B, C. This is your fractions refresher. This is how they work. Okay. So write that down if you need to on your notes. And then we're gonna carry on. I'm gonna assume that you get this. We're gonna work here. Got my eraser. Okay, so we have a rational expression right here and another rational expression. So they're not rational, they're so noisy, there's so much there, but it's okay, we're gonna sort it all out. This one is multiplied together. When we multiply together, it's the same as the top times the top, up top, and the bottom times the bottom on the bottom, okay? So these look like fun with factoring 101. So let's go ahead and factor these. Factor this, factor this, factor this, factor that, and the difference of squares. Okay. Looks like you don't have this in your notes, so I'm just gonna go forward with it. And I'm gonna do x minus 8x plus 3. Cool. 18, they're different. X minus 9x plus 2. How am I so good at this? I am awesome. X plus 8. How about the top one? 22. 22, what factor is that? We got 2 is divisible by 2. 2 times 11. Wow, 2 and 11 equal 13. That works.
Okay. That is fresh.
Okay, copy this down. See you. Thank you for participating. So, I wonder if I missed anybody attendance today. I'll get it later. These are the factors as I have written them. Can everybody read what I wrote? Anybody wanna disagree with what I wrote? Nope, we're good. Cool. So, when we multiply, we turn this into one big happy family and draw that line across. We just combine them together. The top stays up top, the bottom stays down below. So now we're gonna look for stuff that's the same up top and the same down below. Looks like, we'll start with this x minus 8. We got one up here. Looks like we got one down there. So let's go ahead and x minus 8, x minus 8. Great. What else? X plus 3. Don't see one. X plus 11.
Plus 2.
Oh, thank you. Stop me talking. Cool. Okay. Anything else? Looks like x plus 3. X plus 11. And we're going to divide by x minus 9. And x plus 8. That noise is our answer.
Oh.
It is simplified. Do not multiply these together, leave it simplified. Let's move on. We're gonna do a division. If you remember, when we have a division, we take the second guy and we flip him upside down.
If we multiplied it, we would just undo our work, wouldn't we?
Yes.
Okay.
So this x plus 6 is going up top, and this x squared minus 49 is going down below. That's what that means. So when we make our factors, we write out our factors of the first guy. We're okay. Let's leave him as x plus, watch it, x plus 7, x minus 1, here. This guy is x plus 6, x minus 5. Nobody wanted a superhero that can be factoring. I already applied. They said no. We're gonna move that x plus 6 up top. And we're gonna factor the x squared minus 49 difference of squares down below. Who wants to factor that? X squared minus 49.
X plus and minus 7.
Thank you. X plus 7, x minus 7. Okay, so what happened is that divide became a multiply. When you flip that upside down, it's next door to same family, okay? So now we can look for stuff to cancel. What can we find? We've got an x minus 7.
And x plus 7.
I'm sorry, x plus 7, correct. Looks like, anything else?
That's it.
Are we sure that's it? Who said
I mean, x plus 6.
in the back, x plus 6? There
Oh.
we go. I know, you gotta find them all.
I thought I wrote a B.
Okay, that's your answer. When everything else has gone away, x minus 1, and then we've got those two factors on the bottom. Okay? That's how we do division of rational expressions. Doesn't that sound impressive? Yes.
Just want to confirm we're left with 0 on. Never mind. So that's all one problem now. Sorry.
Yep. All right. Let's practice, because we like to do this in our spare time. Okay, so we've got two rational expressions. All right, we've got one of them here. Oh my gosh, what happened to that? Let's not let that happen ever again. And we've got another one over here. We're going to multiply them together. When you multiply them, they just kind of join up. All right. That's kind of how that goes. Multiplies are easy. When you divide, you flip them. We're not doing division here, just multiplication. So let's go ahead and factor that first guy. Looks like x plus 2, x minus 1. That x plus 3 stays up top. On the bottom, we have x plus 4, 1 and an x plus 2. Write that down. Write that down. Okay, cool. So, once we have all these little binomials, little nuggets of binomials, we can look for what's the same up top and on the bottom and start canceling stuff out. Okay, the green stuff, yeah, x plus 2, there we go. That one's an easy one. What else? Anybody? X minus 1 from the back, who is whispering? You can shout, I shout.
X minus
Okay, cool. Yes, x minus 1. And then up top, we're left with just this x plus 3 and this x plus 4 on the bottom. And that's it. This is your answer. Good job. You got it right. There's your 2 points. Okay, any questions what we're doing here? Cool. Alrighty. Ooh, look at this. That's a mess. Not super thrilled about that. I look at that and I wanna like go to sleep. So we got, it looks like we got 3 in a row here. We got 1 here. We got another one. And another one. Oh. Okay. So this first one,
Okay.
yeah,
You just flipped the second one? No.
correct.
Correct, yes.
We have a winner, okay? Which one of these gets flipped? It's this one.
What an emotional roller coaster.
I know. It's nuts, right? I know. So when we start factoring these pieces out, here's the first guy factored out. The second one gets factored out into some 2x squared minus 5x minus 3. How do I do that? Well, so this is my method for doing these, and maybe she's got the same method. I learned everything I know from Miss Barbier. She's pretty awesome. When I look at this guy down here in the denominator, I know it's going to go up top. Why do I know that? Because there's a division here. And when we're doing division, we flip upside down. So 2x squared minus 5x minus 3 is going up top, and 2x squared minus 2 is going on the bottom. So I'm going to go ahead and do a 2, and I'm going to do a 2x squared minus 1. What? X squared minus 1? That looks like we can factor it still, but we'll get to that in a second. Let's deal with that 2x squared minus 5x minus 3. I'm just seeing if I can do some 2. If I steal this, does that equal? Yes, it does. We're gonna have 2x plus 1 and an x minus 3. Okay, I just stole it from down here, but when I do these, I notice that the number attached to the 2 is not a 1, or attached to the x squared, excuse me, is not a 1. So I know that I'm going to do factor by grouping. So I'm going to do my x here. I've got minus 3 times 2x squared. That's on the bottom. And I'm going to drop that negative 5x in here. What multiplied together equals negative 6 and added together? Well, that's how my x looks. Then I do factor by grouping. Not sure if this is all, is this review for y'all?
Yeah.
Okay, cool. So I'll leave that for, skip over it. This, 2x plus 1, x minus 3, that comes from this. Okay? It's the one that got flipped over and moved up top. Are there any questions about how this happened? Good. So we've got one more thing. This x squared minus 1. Okay, difference of squares. Anybody want to say
I'm
what
sorry,
that
I do
factors?
have a question. Why the bottom of the middle one that we worked on, why that 2 stayed outside of the parentheses?
This one?
Yeah.
Because I took a 2 out of this expression. I factored out a 2.
Okay.
Because you can. They each have something I can harvest from the 2x squared and the 2. They have a 2 in common. So I pulled that out, got started on it. I also have to continue to factor this guy. Oh,
Okay, I understand.
it's endless. x plus 1 and x minus 1. That's what that is, okay? So it's all down here. We're gonna rewrite everything. X plus 3, same. X minus 1, here. 3x plus 1, 2x plus 1. I know I'm talking quickly. Y'all can stop me if you want. Raise your hand. No problem. Just recopying what I already wrote. 2x plus 1 here, x minus 3. I got a 2, x plus 1 and x minus 1. And then my third rational expression, I rewrote down here. So let's make this. And there, that's what that looks like. Okay, cool, so let's look for stuff to cancel. That's the next step. Looks like we can cancel a whole lot of stuff. We got 2x plus 1s, cancel out. We got x minus 3s, x plus 1s, x minus 1s. Whole lot of stuff, 1s everywhere. Happy campers, going off to live with each other. Yay. They go away. And this is what we're left with. Just those. That's your answer. Yep.
Sorry, hold on.
It's okay.
Why would you not, oh, I see.
You see it? I know, there's a lot to this one. A lot of terms going on. Yeah. Cool, cool. Okay. We're almost through. We're doing great. Okay. So does everybody remember polynomial long division? Hated it. Hated it. I don't have to do it anymore. Yay. Okay, this is our new method. Factor the thing, cancel it out. You get the same answer.
That's much better.
Much better. Yeah. This sucks. I mean,
Does that mean I
you
never
can
have to
do
do
it,
that?
but- Correct. If you're given
That's wonderful.
this, you don't have to do this. But there's a caveat, all right?
Okay.
It's got to be able to factor. You gotta have something to cancel out, okay? If you go ahead and you factor this one, and you factor this one, if you can, whatever. If you factor both of them and there's nothing to factor out, there's nothing to cancel out,
Then still have
you
to.
still have to do this.
Okay.
But in today's lesson, happily, you don't.
So, almost all the things we've been doing can be solved, like that, with long division?
So I will say this. If you have a rational expression, a polynomial up top, polynomial on the bottom, you can always and forever use this method, okay? Always. But if you can factor those and cancel something out, this is your shortcut, okay? If you get it here and you find nothing can cancel out, you gotta go back. Sorry. But today, here, you're good. You know, this is your example. We're all good. Good questions? I think that's it, campers. We're gonna be doing the practice quiz. So, this is the way I ran it last class. If you're not done with your quiz for day 13 in last class that y'all had, go ahead and work on that. Otherwise, let's work on the practice quiz, okay? Does she require that y'all go to the board to do these?
Sometimes.
Sometimes? Okay. I tell you what, work on your quiz. If you're done with your quiz, work on this. And furthermore, if you got questions with this, put it on the board and I'll come around and we'll do it together. Okay, good. You're done. Well done. I just want to make sure I capture everybody.
You are one, right?
What?
We have
You
Maria? Maria?
Yeah.
Hi. Oh, I'm sorry I didn't get you one. Does everybody have a quiz? Cool. So we don't have Maria and we don't have Aileen. I think that's what it is.
14 or day 12 quiz?
So today is day 14 lesson, so you're gonna be quizzed on day 13, which you do, that's it. So you go ahead and work on that, that's from last class. And turn it into me before you leave. Yeah, for, just a little bit of a recap for me to come in late, this is what's due to me today. Day 12 stuff and day 13 stuff. Cool.